सो एक बार फिर से हम और आप साथ हैं। आज हम लोग अपने लाइव लेक्चर सीरीज का छठा लेक्चर, सिक्स लेक्चर शुरू करने वाले हैं। पिछले 5 लेक्चर्स में हम लोगों ने देखा, we have seen about the rectifier, we have seen the two transistor model of the rectifier, two transistor model of the thyristor. We have seen the series parallel combination of the thyristor, the challenges which are in series parallel combination, and how to rectify those challenges that we have seen. We have seen the commutation techniques, we have seen the VI characteristic as well. Now the next topic which I am going to start is rectifiers. Rectifier which are used to convert AC into DC. This we are going to start, right? So जैसा कि हम सबको पता है, as we already know that the rectifiers are used to convert AC into DC. The use of AC-DC rectifiers are in AC drive, where we require the DC link for our inverter. There we use this. We also use AC-DC rectifier in case of HVDC transmission. At the sending end we convert AC into DC, then at receiving end we convert DC to AC. We also required for speed control this AC to DC conversion, right? So these AC to DC rectifiers are classified, number one, on the basis of number of phases. It could be single phase, it could be 3-phase, or it could be multi-phase. In upcoming lecture, when I'll tell you something about research related topic, then we will discuss this multi-phase rectifiers as well. Other category is number of pulses per cycle. For example, if it is a half wave rectifier, then only one pulse would occur per cycle. If it is a single phase full bridge or central tap type, then 2 pulses would occur. If it is a 3-phase half wave, then 3 pulses would occur. Likewise for full wave 6. And if it is a multi-pulse converter, we talking about the lesser size which is used for reducing the harmonic content, then it could be 12, 18, 24 or 48 pulse. Another criteria is it could be uncontrolled, like diode based rectifier. It could be controlled rectifier like thyristor based rectifier. It could be semi-controlled, means where we control only the half cycles, something like that, right? Then we have the half wave as well as full wave controlled. Clear? These are the various type of classification for AC to DC rectifier. लेक्चर यूट्यूब पे लाइव है, इन केस आपको कोई कमेंट हो प्लीज बता दे, तो उस हिसाब से जो है इसको चेंज कर लिया जाएगा। अगर स्पीड तेज हो तो बता दे, धीमी हो तो बता दे। इफ स्पीड इज फास्ट टेल मी, आई विल स्लो माय स्पीच। इफ इट इज स्लो then tell me, I'll make it fast, right? The very first topic which we are going to discuss is single phase half wave rectifier. Single phase half wave rectifier, that we are going to study first, right? For that I have considered one transformer generally which is used to lower down, step down transformer is being used. For example, in your mobile charger, what you do, you use 220 volt and get 5 volt DC, so there must be one transformer. So this is the primary of transformer and this is the secondary of transformer, and let us say the secondary voltage Vs is given by Vm sin omega t. Vm sin omega t, this, where Vm is the peak amplitude and omega is angular frequency, and this is the thyristor. See, this is the thyristor, and this is your load resistance which you have connected as a load. Now this is the circuit. So let us draw the waveform of this, and here I am not discussing the uncontrolled rectifier, means we are not discussing the diode based rectifier. The reason is, if you use diode based rectifier, it will give you the fixed supply. It will give you the fixed supply because you don't have any control over the diode firing angle, because there is no question of firing angle. The moment diode come in the forward bias, it will start conducting. So you don't have any control. That is why we are discussing the thyristor, means control rectifier we are discussing. And if you put firing angle 0, it will act as a diode based rectifier. So that thing I am not discussing. Fine. Now this is our supply. This is our supply. And we trigger the device at an angle alpha. Now what is alpha? Alpha is the firing angle by which conduction of thyristor is delayed, and it is measured from the instant where device come forward bias with purely resistive load. अर्थात जितनी देर को हमने कंडक्शन थायरिस्टर का डिले कर दिया है, उस डिले को ये मेजर करता है या मानता है, और कहां से शुरुआत करनी है? वी हैव टू मेजर दिस डिले फ्रॉम द इंस्टेंट वेयर दिस डिवाइस कम इन द फॉरवर्ड बायस. सो दिस इज द जीरो क्रॉसिंग. यहाँ पर डिवाइस फॉरवर्ड बायस में आई है, इससे कितनी देर हमने कंडक्शन इसका डिले कर दिया, अल्फा डिले कर दिया साहब. नाउ व्हाट हैपेंड? द मोमेंट इट इज ऑन, इट विल एक्ट एज ए शॉर्ट. So output voltage would follow the input voltage. जो कुछ भी आपका input voltage होगा बच्चा पार्टी, वो इसमें output में आने लगेगा. And what would be the value of current? Current would be Vm by R, right? So it is Vm. It is Vm sin omega t by R. So it will follow the voltage divided by resistance R. Now if we talk about the thyristor voltage, what would be the thyristor voltage? So thyristor voltage would be always anode minus cathode, anode minus cathode. Unless until it is not conducting, it will give you this. Once it is conduct, it will give the zero voltage, and here it is in reverse bias, right? तो अब अगर एवरेज आउटपुट वोल्टेज निकालना हो आपको थायरिस्टर का, तो क्या हो जाएगा? इट इज गिवन बाय VDC इज इक्वल टू 1 अपॉन टाइम पीरियड. टाइम पीरियड यहाँ पर क्या है? 2 पाई. कहां से कहां तक आ रहा है वेवफॉर्म? कहां से कहां तक आ रहा है? अल्फा से लेके पाई तक. अल्फा से लेके पाई तक Vm sin ओमेगा टी, जो कि इसमें जो भी इनपुट वोल्टेज है, जो भी इनपुट वोल्टेज है वही तो आ रहा है भाई मेरे. So it is equal to Vm sin omega t, as simple as that, right? It is come out to be Vm upon 2 pi 1 plus cos of alpha. Average output voltage is come out to be Vm sin ओमेगा टी को इंटीग्रेट कर दिया अल्फा से पाई तक, इट इज कम आउट टू बी Vm अपॉन 2 पाई 1 प्लस cos ऑफ अल्फा. नाउ मैक्सिमम आउटपुट वोल्टेज क्या हो जाएगा? इट इज डिनोटेड एज Vdm एंड गिवन बाय cos अल्फा की अधिक से अधिक वैल्यू क्या हो सकती है? 1. सो 1 प्लस 1 2, 2 and 2 get cancel out, it is come out to be Vm upon pi. Now normalized output voltage क्या है? It is defined as VDC divided by VDM. So it has come out to be half 1 plus cos of alpha. Now finding angle की definition आप लिख सकते हैं, is the angle by which conduction of the thyristor is delayed, and it is measured from the instant that gives the largest average output voltage to the instant at which thyristor is triggered. तो लार्जेस्ट आउटपुट वोल्टेज कहाँ से आएगा? जहां से ये फॉरवर्ड बायस में आएगा, तुरंत जीरो से इसको ट्रिगर कर दीजिए. as the case of single phase rectifier. Now RMS, it is the root mean square. Root mean square. So Bm sin ओमेगा टी इज द आउटपुट. कहां से कहां तक आ रहा है? ये अल्फा से लेके पाई तक आ रहा है. स्क्वेयर कर देना है, एवरेज कर देना है और रूट ले लेना है. इट इज कम आउट टू बी Vm upon 2 pi pi minus alpha plus half sin 2 alpha. Right? Now एवरेज आउटपुट करंट की बात करें हम तो VBC by R. जो भी कुछ हमारा VBC आया है, VBCm upon 2 pi 1 plus cos of alpha. So it is come out to be Vm upon 2 pi R 1 plus cos of alpha. Right? So it has come out to be this. Now power dissipated. See this was the Vm2 upon 2 pi 1 plus cos alpha. So it is Vm upon 2 pi 1 plus cos alpha divided by this R. Right? So that is the output current. Now power delivered to the resistive load क्या हो जाएगी भाई? ये हो जाएगी RMS load voltage multiplied by RMS load current. So जो भी RMS load voltage है, that is VRMS, current is IRMS. So it will come out to be VRMS square by R, or we can write it IRMS square R. Right? Now input volt ampere is RMS source voltage divided by total RMS line current. So it is come out to be, let us say, RMS source voltage is RS and RS is RMS source voltage is Vs and RMS line current is IRMS. So IRMS is equal to come out to be this. From here we have calculated. This is given. VRMS, this is given. VRMS divided by R is divided by R. V S square, this would become Vs square. Here Vm is equal to under root 2 Vs, right? So it has come out to be this. Now input power factor is power delivered to the load divided by input volt ampere. So it has come out to be Vs into IRMS. IRMS get cancelled out. It is finally VRMS by this is the this we have taken power delivered to the resistive load is RMS load voltage multiplied by RMS load current. It is come out to be IRMS square times R, and input volt ampere is come out to be RMS voltage divided by total RMS line current. So it is come out to be this. Now input power factor is power delivered to the load divided by input volt ampere. It is come out to be 1 by under root 2 pi minus alpha plus half sine 2 alpha whole square, right? And if it is a RL type load, this is our source voltage. We trigger the device at an angle alpha. The moment you trigger, output voltage start to come, and this is your current. जब तक you can see at angle pi, device applied voltage is negative. After this it is negative. But inductor is developing a polarity such that current is keep on flowing. And when the current is flowing, that means this device is off. So this device is on, and when this device is on, whatever the input voltage that will come across output. So this angle is alpha, this angle is beta, and this is gamma. Gamma is beta minus alpha is equal to gamma. Right? Here you can see. Now, one thing you should notice, our thyristor is in reverse bias for the duration. How much? For this duration. right? Here it is positive and here it is conducting. So 2 pi minus beta, 2 pi minus beta divided by omega. Omega t is equal to 2 pi minus beta. So t is equal to this. This is the time during which our thyristor is in reverse bias. It means what? It means our thyristor turn off time must be such that it must be less than the circuit time during which thyristor was in reverse bias. जितनी देर तक हमारा थायरिस्टर रिवर्स बायस में रहा उतनी देर में सर्किट टर्न ऑफ थायरिस्टर टर्न ऑफ टाइम उससे कम होना चाहिए फॉर सक्सेसफुल कम्यूटेशन. Our device has to be in reverse bias for the duration more than the turn off time. That is the point. गेट में ऐसी सिंपल सिंपल से सवाल आ जाते हैं लेकिन हम लोग कर नहीं पाते हैं तो फिर दिक्कत आती है बेटा. अगर हम लोगों ने फंडामेंटल, इफ यू अंडरस्टूड द फंडामेंटल, then no competitive exam is difficult, right? Now the voltage equation, we have to calculate the instantaneous value of current is, how this current is flowing, this we have to derive the equation for this. For that I have considered that this current would have two components. One is steady state and other one is transient state. This is ISS is ISS is steady state and IPR is transient state. Right? So this is our steady state value which is equal to under Vm by Z sine of omega t minus phi, where Vm is equal to under root 2 Vs and Vs is RMS voltage of the supply. So it has come out to be under root 2 Vs by Z sine of omega t minus phi, where Vs is the RMS of the supply voltage and the phi is given by 10 inverse omega L by R. And Z is as usual R square plus omega L square. Now for transient state, it is given by A to the power T by tau, where tau is equal to L by R. Now after putting all this value, it is a very simple calculation and applying the boundary condition, that is omega T equal to alpha, I0 is 0. What we get? We get this. I0 is Vm by Z sine omega T minus phi, Vm by Z sine alpha minus phi e to the power omega e to the power R by omega L omega T minus alpha. Right? Now if we put omega T equal to beta, I0 is come out to be 0. So after putting this, what we get? Sine beta minus phi is equal to sine of alpha minus phi e to the power minus R by omega L beta minus alpha. This is Transcendental equation. The solution of this type of equation is little bit complex. So हम लोग क्या करते हैं भाई? हम लोग approximation method apply करते हैं. We assume that for omega t this value the current is 0. Yes, that will give you the value of beta. If it is not coming, we will change and put again unless until we find the value closer to 0, and that omega t value is equal to beta. Now for this case, average output voltage is 1 upon 2 pi alpha to beta Vm sin omega t. It is come out to be Vm by 2 pi cos of alpha minus cos of beta. Similarly, if we talk about the average load current is equal to I0 divided by is equal to V0 by R, where V0 is Vm upon 2 pi cos of alpha minus cos of beta. Average output voltage, which we have already derived some time before. Similarly, RMS output voltage is VOR, which is equal to root mean square Vm sin omega t ka square, and we have to calculate this. It has come out to be Vm upon 2 under root pi बीटा माइनस अल्फा माइनस हाफ साइन 2 बीटा माइनस साइन 2 अल्फा का अंडर रूट, that we will get, right? So in this way, this is the single phase half wave rectifier, right? Single phase half wave rectifier. Now another concept, effect of freewheeling diode. The another concept is effect of freewheeling diode. In this, what we do, we connect one diode which is known as freewheeling diode. It will come in the picture when supply is disconnected. Whenever the voltage of a node is greater than cathode. मेरी एक बात हमेशा याद रखिएगा, जब भी कभी किसी डिवाइस का चेक करना हो कि वेदर इट इज इन फॉरवर्ड बायस और रिवर्स बायस, क्या करना है आपको भाई, आपको सिर्फ एनोड माइनस कैथोड करना है। किसी भी डिवाइस ये चलेगी नहीं चलेगी, फॉरवर्ड बायस में है या नहीं, कैसे चेक होगा, एनोड कैथोड, बस सिंपल फाइंड, एनोड वोल्टेज माइनस कैथोड वोल्टेज, एनोड वोल्टेज माइनस कैथोड वोल्टेज, दैट्स इट। अभी तो नहीं, लेकिन जब 3 फेज पढ़ाऊंगा तो फिर ये कॉन्सेप्ट को याद रखिएगा। ओके, लेट अस स्टार्ट। V average is 1 by 2 pi टाइम पीरियड अल्फा टू पाई, जहां तक हमारा आउटपुट वोल्टेज आया अल्फा टू पाई। क्यों पाई के बाद नहीं आ पाएगा, क्यों नहीं आएगा अभी हम बताएंगे। इट इज कम आउट टू बी Vm upon 2 pi 1 plus cos of alpha. Now let us see after pi what happened. After this instant, this plate would become positive and this would become negative. So diode come in the forward bias. So diode come in the forward bias and this current will start flowing here. So this duration is 0 for that period. क्यों भाई? उस पीरियड के लिए ये हमारा 0 आ जाएगा। ड्यूरिंग दिस पीरियड हमारा ये 0 हो जाएगा। नाउ जैसे ही पाई के बाद ये 0 हुआ, करंट यहां से यहां फ्लो होने लगे, करंट यहां से यहां फ्लो होने लगी। तो जिस ड्यूरेशन में पाई से लेकर के बीटा तक जो ये जाता था, इसमें ये अपोज करता था सप्लाई वोल्टेज का। जो करंट, जो इंडक्टर में जो एनर्जी थी वो उसको अपोज करना होता था सप्लाई वोल्टेज का, अब नहीं करना है। तो ये और दूर तक जाएगा करंट, ये और दूर तक जाएगा। हाँ, और ऐसा भी हो सकता है कि ये आगे तक चला जाए, तो फिर ये कंटिन्यूअस मोड ऑफ कंडक्शन बन जाएगा। अप टू पाई तो थायरिस्टर चलेगा एंड आफ्टर दैट फ्री व्हीलिंग डायोड चलता रहेगा। तो करंट would become like this, current would become like this, right? It is possible only when this load inductor is quite high. अब इसमें एक फायदा हो गया। फायदा क्या हो गया, इसमें कभी भी वोल्टेज हमारा नेगेटिव नहीं है, करंट भी ऑलवेज पॉजिटिव, वोल्टेज भी पॉजिटिव। तो इसका मतलब ये हुआ इनपुट पावर फैक्टर जो है वो हमारा इंप्रूव हो गया। साथ ही साथ लोड करंट वेव फॉर्म भी इंप्रूव हो गई। तो चूंकि लोड करंट की वेवफॉर्म इंप्रूव हुई है, लिहाजा हमारी परफॉर्मेंस भी इंप्रूव हो गई, राइट? तो दिस इज द एडवांटेज ऑफ दिस फ्री व्हीलिंग कनेक्टेड हाफ वेव रेक्टिफायर। तो डायोड कहाँ लगाएंगे भाई? जब डायोड लगा देंगे तो जो है फ्री व्हीलिंग होने लगेगी। फ्री व्हीलिंग करने के लिए हम लोग इस डायोड को लगाते हैं। क्लियर? सो आज के लिए है इतना ही। कल हम लोग पढ़ेंगे नेक्स्ट लेक्चर में सिंगल फेज फुल वेव कन्वर्टर, राइट? तो दो तरह के कन्वर्टर है, सेंट्रल टैप और दिस ब्रिज टाइप कन्वर्टर, दैट वी विल सी इन नेक्स्ट लेक्चर। तब तक यू कीप ऑन डूइंग स्टडी योर ओन। मैंने लेक्चर अपलोड कर दिए। आई होप कि आपको इससे फ़ायदा मिल रहा होगा। आप मेरे चैनल को सब्सक्राइब कर सकते हैं ताकि जब भी मैं अपलोड करूंगा आपको पता चल जाएगा। दिस इज माय लिंक्डइन प्रोफाइल, दिस इज द चैनल QR code. If you wish, you can scan the code and connect me on Insta, as well as this is my WhatsApp number. So bye bye, take care. I hope you enjoyed the talk. Bye bye.